All right, so we are continuing with the big idea. Understanding improper fractions, mixed numbers, ratios, and percents helps us to describe and compare quantities. Remember, quantities are amounts. Our concept specifically for today is to demonstrate an understanding of a ratio. This will be found in Unit 5, Lesson 4 and 5. There are some other sources as well on the video, so you may not find it in your textbook. And of course, we're looking at the Connect section. So let's begin with what ratio is. Ratio is a comparison of two quantities with the same unit. So you are comparing one rabbit to one rabbit, but in this case you're comparing brown rabbits to white rabbits. There are 4 brown rabbits to 5 white rabbits. We would write a ratio in this way: 4 colon 5, or 4 to 5. The order is very important. You cannot write 5 to 4 because you are no longer then talking about brown to white rabbits. You are then talking about white to brown rabbits, which is different. So you cannot. You have to go in this order: brown to white. You cannot change that order. We could also use ratios to compare the number of white and brown rabbits, where we're having white first. So now we would go 5 to 4. It can also be written as with a colon, 5 colon 4. The ratio of brown rabbits to white rabbits is 4 to 5. This is considered a part-to-part ratio because we're talking about part of the rabbits and part of the rabbits. Same thing with the white to brown rabbits and the brown to white rabbits. Doesn't matter what order. They are both still part-to-part ratios. The numbers 4 and 5 are the terms of the ratio, and order is important in a ratio. As we discussed already, you cannot switch the order around. 5 to 4 is not the same as 4 to 5. If we are talking 5 to 4, we're talking white rabbits to brown rabbits. If we're talking 4 to 5, it's brown to white. So that order is important. Make sure you pay close attention in the question what the order is that you are to be looking at the items in. So in this case, we were looking, brown to white. And in this case, we were looking, well, up here, I guess, brown to white, and then here it was white to brown. So be careful in your reading of your questions. There is another way to look at ratios. We can compare parts to the whole. So we could say, how many brown rabbits are there to all rabbits? At which point it would be 4 to a total of 9. So 4 to 9. We can write that with the word to. We can write that with the colon. Or we can write that now as a fraction. We can only do that when it is a part to whole ratio. So it can be 4 to 9, 4 colon 9, and it can be 4 over 9. You can only write it in this fraction form if it is with the total being the number on the bottom. This then becomes a part to whole ratio. It is not then a part to part ratio. Okay. Let's continue here. If we were now talking about white rabbits to all rabbits, it would be 5 to 9, or 5 colon 9, or again 5 over 9, because this is a part to whole ratio. The bottom number is the total. All right, now you're going to practice. I will read you the question and you will press pause and do the answer. Remember, the answer needs to be done on paper and cannot be done on your head. And you must do the practice questions. You cannot choose not to do the practice questions. So let's read the first one. Charles bought a dozen of cinnamon buns to his friend's house. A dozen, remember, is 12. We can actually see that from the picture. Charles likes frosting, but his friend does not. So he only frosted some of the cinnamon buns. These would be the frosted ones. write the ratio of frosted cinnamon buns to unfrosted cinnamon buns. Go ahead and press pause and do that now. All right, let's take a look. So we were looking at frosted to unfrosted. How many are frosted? 3 are frosted. How many are unfrosted? 9 are unfrosted. We can go 3:9. We can go 3:2:9. Is this a part to whole ratio? No, our bottom number is not the total number of cinnamon buns, so we cannot write this in the fraction form with the line in between. All right, you are going to now use the alphabet to write the following part to whole ratios. Here we have the alphabet. You are comparing vowels to total letters. A vowel, again, is your A, E, I, O, U. They say sometimes Y. We're not going to count Y this time, so remember vowels are A, E, I, O, U. You're comparing vowels to total letters. And then you are comparing consonants to total letters. Consonants are any of the letters that are not vowels. So go ahead and press pause and do those two ratios now. All right, so let's take a look. Vowels, we have 1, 2, 3, 4, 5. So we would have 5 to a total of 26 letters in the alphabet. Could also, of course, be written 5 to 26. This is a part to whole ratio, so it could also be written 5 over 26. Remember, if you can show it more than one way, that's a great extra, so showing it all 3 ways would be perfect. B, consonants to total letters. Well, total letters we already know is 26. Consonants we can find out from the number of vowels. If there's 26 letters altogether and we know 5 of them are vowels, the ones that are left are the consonants. So 26 minus 5 is 21. That means we have 21 consonants. Can also be written as 21 to 26, and of course 21 over 26. All right, the last one that we're looking at. We are looking at a school parking lot. We are writing part to whole ratios, comparing the number of cars to the total number of vehicles. So cars are all the white ones. They're smaller. B, I'll read through all the questions and then you can do them. B, write a part to whole ratio comparing the number of SUVs to the total number of vehicles. SUVs are the gray ones. They're the larger vehicles. And remember, if it's a part to whole ratio, you should be writing it all 3 ways. Then you're going to write a part to part ratio comparing the number of cars to the number of SUVs. Lastly, you're going to explain which ratio best shows the type of vehicles most teachers would drive. So that uses some of your background knowledge there. That's a little bit interesting, that one. We'll talk about that one after. All right, press pause and go ahead and try each of those. All right, well, let's take a look. So we have the number of cars to the number of total vehicles. Cars, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 to a total of 10, 11, 12, 13, 14 and 9 to 14, and this is a part to whole ratio, so 9 over 14. B, the number of SUV vehicles, 1, 2, 3, 4, 5. We already know the total is 14. 5 to 14. And 5 over 14, that is a part to whole ratio as well. C is a part to part ratio, and it's the number of cars, which we know, and the number of SUVs, which we know. So 9 to 5. 9 colon 5 that was actually, and 9 to 5. We cannot write this one as a fraction because it is not a part to whole ratio. Now, last question. Of these 3 ratios, which one would best show the type of vehicle most teachers drive? Well, if you look at the number of vehicles that we have here, there are more cars than there are SUVs. So the better ratio to go with this statement, which type of vehicle do most teachers drive, it would be 9 to 14. Interesting. Because if you look at our school parking lot currently, and the fact that we live in Alberta and we don't have the greatest roads, in our case, we have more SUV vehicles than cars, but just interesting to take a look at. In this case, this statement would best match this particular ratio because we do have more vehicles that are cars than our SUVs. All right, we are combining this lesson with ratios with also equivalent ratios, which is the next lesson. So you're now moving on to the next Connect section. Very, very similar to equivalent fractions, and that's why I think you'll be able to manage it just fine because you are very good at equivalent fractions. It is again the same idea. You multiply by the same number, but now you're doing it with the front number and the back number instead of the top and the bottom number. Oh, that's supposed to be a 3. So 5 to 3, for example, is going to be our ratio. So we can multiply and in some cases divide by the same number with the front and the back instead of the top and the bottom. So for example, here we can say, okay, say we're going to have groups of plants, and in our groups of plants we're going to have 5 daisies for every 3 petunias. So if we want to have 2 sets of those plants, we're going to have to multiply by 2 to both the front and the back number, and which leaves us with 10 to 6 would be our equivalent ratio. If we wanted to triple it, times 3 with each, again, we're going to do the same thing to the front and the back number. We're going to multiply by 3. So 15 ninths would be our equivalent ratio. And again, you can see here they're going to do the same thing. They're going to multiply by 4, groups of 4 now. 5 times 4 is 20. 3 times 4 is 12. So that would also be an equivalent ratio. So we could say that 5 to 3, 10 to 6, 15 to 9, and 20 to 12 are all equivalent ratios. Exactly the same for ratios as it is for fractions. Same thing to the front and back number. Just like with fractions, it would be the same thing to top and bottom number. Now let's take a quick look at one with division. Our textbook didn't show us one with division. Let's make one up. Say I was looking at the number of pencils to the number of erasers. Say I had 20 pencils and I had 16 erasers. What could I divide both of those numbers by? Well, 20 can be divided by 4. 16 can be divided by 4. Let's try divided by 4 to both sides. 20 divided by 4 is 5. 16 divided by 4 is 4. So 5 to 4 would be an equivalent ratio. I could go a different way if I wanted. I could divide by 2 instead for both of those. 20 divided by 2 is 10. 16 divided by 2 is 8. That would also be an equivalent ratio. So equivalent ratios, just like equivalent fractions, can be multiplying or dividing, but it has to be by the same number to both the front and the back. All right, now it's your turn to practice. You're going to write 2 equivalent ratios for each one. Remember to show your work. Remember to do it on paper. Remember, you are doing the same thing to the front and the back number, and it's your choice. You can multiply with whatever numbers you want. You can divide if that's possible. Make sure that it is in fact a possible thing that you can do. So be careful about that. Go ahead and press pause and do that now. All right, let's take a look. A, we have 3 to 1. What could we do? We could multiply both by 2, for example. 3 times 2 is 6. 1 times 2 is 2. That would be an equivalent ratio. What else could I do? 3 to 1. Let's multiply by 3 to both numbers. 3 times 3 is 9. 3 times 1 is 3. So 9 to 3 would be an equivalent ratio. You might have chosen different numbers. As long as you have multiplied by the same number to the front and the back, we are okay. Let's try 4 to 2. I'm going to multiply by 2 this time. 4 times 2 is 8. 2 times 2 is 4. With this one, I could actually divide, so I'm going to try dividing for my next one. I'm going to divide by 2 for each. 4 divided by 2 is 2. 2 divided by 2 is 1. So 2 to 1 could be an equivalent ratio. All right, let's try C. We have 1 to 2. I'm going to try a bigger number this time. I'm going to times by 5 for each. 1 times 5 is 5. 2 times 5 is 10. What else might I try? 1 to 2. This time I'm going to multiply by, maybe go by 4 for each. 1 times 4 is 4. 2 times 4 is 8. So 4 to 8 could be an equivalent, or is an equivalent ratio. F. We jumped there. 4 to 9, what could I do? I'm going to times by 2 to both. 4 times 2 is 8. 9 times 2 is 18. That's an equivalent ratio. What else could I do? I'm going to multiply by 3. 4 times 3 is 12. 9 times 3 is 27. That's also an equivalent ratio. And lastly, let's take a look at G and H, 7 to 8. I'm going to multiply by 2 for both. 7 times 2 is 14. 8 to 2 times 2 is 16, so 4 to 16. 7 to 8. This time I'm going to multiply by 4 for each. 7 times 4 is 28. Sorry, my colons are hard to do with the iPad pen. 8 times 4 is 32. Would be equivalent. H, 8 to 3. I'm going to multiply by 3. 8 times 3 is 24. 3 times 3 is 9. That would be equivalent. Let's see, 8 to 3. Let's try times. Maybe we'll go times 5 this time. We'll make it a bigger one. 8 times 5 is 40. 3 times 5 is 15. That would also be an equivalent ratio. So it doesn't matter what numbers you decided to multiply by, but you would, of course, have to multiply the front number and the back number by the same number. All right, now you're moving on to the concept practice. Page 78 and 79, numbers 2, 3, and 5 are just ratios. And page 182, numbers 2, 5, and 7 are moving on to equivalent ratios. So that's your work today. Again, for those of you that forget your textbook, here's questions 1 to 2 of the first, 3 to 5, 6 to 9, and 10 to 11, along with the reflect prompt. That was for ratios. Here are the questions for equivalent ratios 1 to 5. Here you have questions 6 to 9. Here you have questions 10 to 12. And here you have the reflect prompt. Make sure as you're working, if at any point you have any questions, that you remember to ask either myself or the aide in the classroom.